Hi, everyone. Welcome to the Tech Talk Managing Amazon Linux Workspaces at Scale using AWS OpsWorks for Chef Automate. My name is Hassan, and I'm a Senior Product Manager with Amazon Workspaces. In today's talk, first we will do a little bit of introduction about Amazon Linux Workspaces for some of the folks who are new to the service. We will then review what is AWS OpsWorks for Chef Automate, what sort of capabilities it provides. Then we will take a look at what sort of capabilities Chef Automate itself can provide. And then we will actually implement a management architecture in which Amazon Linux Workspaces can be managed from Chef Automate pane of glass view using AWS OpsWorks. So let's get started. Amazon Linux Workspaces, as many of you might already know, are a cloud-managed desktop as a service. They are based on Amazon Linux 2, and some of the key things that we want to discuss here would be that they are pay-as-you-go model, so you can use Amazon Linux Workspaces on a monthly or hourly billing basis. They're secure because all of your data stays in the cloud and your developers can have access to this Linux desktop environment that you can then use to do all sorts of coding, to configure your web servers and AWS artifacts. They're simple to deploy and manage. So compared to existing Linux workspaces or Linux desktops, you will notice that with Amazon Linux Workspaces, it's a few click operation to set up an up and running Linux desktop that you can provide to your end users. And finally, Amazon Linux Workspaces are well integrated with AWS tools. And what that means is that you get AWS CLI out of the box in the image. You can configure it and basically run code on all of your AWS artifacts. So quickly switching a little bit into what is AWS OpsWorks for Chef Automate. AWS OpsWorks is a service that provides fully managed Chef Automate servers. They also provide fully managed Puppet servers, but this talk is going to focus on the Chef Automate piece. This fully managed perspective means that you can quickly configure and provision a Chef Automate server within minutes, which means that you don't need to additionally install any Chef servers, those sorts of software that you have to manually do if you were, for example, running an EC2 server or an on-premises server. All of that heavy lifting is now done by the AWS OpsWorks service. Once you have that server running, this is your management server that is going to be managing your Amazon Linux workspaces. Obviously, you want this server to be continuously updated, continuously patched with the latest security updates. And at the same time, you do want that to be automatically backed up, just in case you want to revert to a previous state of your server. So all of this heavy lifting is done by AWS OpsWorks service. Now, there's many more details attached to it. For example, once you have this server set up, how do you schedule your maintenance? How do you schedule your backups? And we'll take a look at all of that today. And then finally, let's talk a little bit about what you can achieve with AWS OpsWorks for Chef Automate. So frequently, customers have asked us, especially in terms of with Amazon Linux Workspaces, that they want to be able to automate compliance and security testing of their Amazon Linux Workspaces fleet. Now, that fleet could be in hundreds of instances or thousands of instances, so it's not really humanly possible for you to do it one by one. Then the second thing that we get frequently asked for, that how can we apply configuration across my fleet? So there's two elements to that configuration changes. One is making the change, and then second is to keep it in that state that you basically configure. Then finally, many customers ask us, hey, I have Windows workspaces, then I have Linux workspaces, then I have some on-premises desktops, and how do I do that in a single pane of glass way, basically through one console? So AWS OpsWorks for Chef Automate provides you the capability to configure all of your resources, desktop resources in this case, as nodes. These nodes are effectively considered as management resources from Chef Automate perspective. So all of these capabilities are given to you using AWS OpsWorks for Chef Automate, and the key piece here is that this Chef Automate server is fully managed and fully backed up regularly. So let's do a little bit of dive into what Chef Automate does. So now we have reviewed that we have AWS OpsWorks that can provide you a Chef Automate server, which is fully managed. We reviewed that it allows you to do certain actions, the common actions that we discussed, like compliance and security, configuration management, as well as keeping management of your hybrid fleet. So Chef Automate itself is effectively an automation tool that can perform operational tasks at scale. And I understand that operational task is a very broad word, but that's exactly what it can do. It can do anything that you can imagine, because it is relying on a code base to effectively manage and control your infrastructure. Which brings us to the next point. What do we mean when we talk about infrastructure as a code? You will hear that word being thrown out pretty broadly, that Chef Automate provides you the capability to run infrastructure as a code. What that means is that Chef treats infrastructure resources as part of its code. And the code that it uses is based on Ruby language, which is an object-oriented language. It uses artifacts called cookbooks and recipes to describe the desired state of the configuration. In our use case today, we are looking at Amazon Linux workspaces as those resources that Chef Automate can manage. So if you think about it holistically, Chef Automate server has a set of cookbooks which contain recipes. And these cookbooks and recipes effectively have the code for configuring your Amazon Linux workspaces and keeping them at that desired state. Chef Automate does that using something called client run. It goes and effectively converges all of your nodes and your connected systems to one desired state. So you can think about it as a very simple server-client convergence model, which means that once your Chef Automate server have a definition of certain cookbooks and definition of certain configuration and recipes, it is going to make sure that all your nodes converge to that configuration. And if it doesn't, it's going to tell you why it's not in that desired state. So this is the capability we discussed. And one of the things that people frequently ask is, kind of the clarification on cookbooks and recipes. So recipes are basically a simple, configuration tool. And then basically it is the most basic configuration of your resource. And cookbooks are, could be a combination of recipes or a scheduled kind of run list of how which order the recipes are going to be executed. So put things into perspective. What you can do with these capabilities is that you can configure Amazon Linux workspaces, which means that you can configure. Let's say you want to configure a specific setting on the workspace's desktop. Let's say you want to configure a Kerberos certificate on all your Amazon Linux workspaces fleet. Similar tasks, you can say that I want a certain certificate on my Amazon Linux workspaces fleet. You can say that I want to configure a certain sudo access for a certain new user that is not the user that is actually using the workspace. You can perform that task as well. So these are some of the use cases that you can use to configure your Amazon Linux workspaces as they are getting launched. So some more things you can do in terms of configuration management. You can install packages. You can enforce versions of those packages. So for example, you can say that all your Linux workspaces should be at Python 3. And you can enforce that all of your workspaces are at Python 3 or a certain version of Python 3. Similarly, you can configure specific access and controls on your Amazon Linux workspaces, such as SSH. You can configure a certain way of doing SSH on your workspaces. You can configure an additional SSH user, for example, to access your workspaces. This SSH user could be something like your Chef Automate server that is running commands silently without using the SSH of your named user. You can similarly configure sudo or sfile to have additional sudos or to restrict sudo. And then finally, you can also do things like disabling clipboard. So one of the common asks that we get is that I want to configure PC over IP clipboard to be disabled for my user. For those of you who are new to Amazon Linux workspaces, PC over IP is the streaming protocol that is used to stream Amazon Linux workspaces desktops to a user. And this streaming protocol effectively controls what type of channels are available. So if you are talking about audio channels, you can configure settings there. You can also configure settings such as we discussed, where you're disabling clipboards. And finally, one of the bigger asks that we always get from customers is, I want to have security and compliance benchmarking and remediation set up for my Amazon Linux 2 instances, whether they're EC2 instances or Amazon Linux Workspaces instances. So you can do that as well. You can scan your fleet to benchmark against CIS, OS hardening benchmarks, and you can see what are the problems in your image or in your machine that you want to fix. So with that, we will switch into what we will do today. So today we are going to do a pretty simple architecture. We are going to simplify the deployment of this architecture. There are definitely multiple ways to achieve the same results, but today we are going to take some paths which will make it easier for you to manage Amazon Linux workspaces at scale. So first of all, what we will do is that we will set up a Chef Automate server using AWS OpsWorks. Once we have that server up and running, we will basically go and use one Amazon Linux Workspaces machine to create an image, or basically to register it as a node to the Chef Automate server. Now, this step is important because today I'm using an Amazon Linux Workspaces as my image preparation machine, as well as my workstation for Chef development. So a little bit of detail on that front is that what we want to achieve is that we want to be able to create a workspaces image from which, a custom image, from which you can create a custom bundle for workspaces, following which every workspace that you launch from that bundle will automatically be registered to the Chef Automate server. So that's our first goal for today. The second goal for today is that once I have these couple of nodes being registered to Chef Automate server, we will run some benchmark testing on those nodes. And then finally, we will do a quick overview of configuration management actions that you could do, such as disabling of PC over IP clipboard. Now, we won't go too much into detail on the cookbooks and recipe side today, but that is something that we will leave for some other day. So let's start with the first one. So as I mentioned, in the first step, we will be setting up a Chef Automate server using AWS OpsWorks. So I'm going to switch into my management console. So this is a common AWS console for management. You will go into into OpsWorks service, and then you will be able to see this kind of window where you can create a Chef Automate server. I have actually created one as part of this lab, and I just created just because it takes about 20 minutes to set it up, but we will go through the whole setup in this talk. So simply, I will go here. You can pick any name for your Chef Automate server. You can call it WS Test 2. You can pick a region where you will be. Ideally, it's a best practice to keep your Automate server in the region where you will have your workspaces as well. And in case you have multiple region deployment, a best practice is to have multiple Chef Automate servers, but converge them through VPC peering or some sort of network connectivity. You can select an EC2 instance here. This is really depending on the number of nodes that you want to manage. So if you have, and nodes here are Amazon Linux workspaces again. So if you're supporting up to 200 Amazon Linux workspaces, you will use an M5 large. If you're using up to 500, you will use R5.X large. If you're managing more than 500 Amazon Linux workspaces, you will use this higher instance type. For this talk, I will just use the basic one. So this, you'll get to the next step where it's going to ask you if you want to connect to your Chef Automate server using SSH or not. Generally, you will be able to give commands to your Chef Automate server using the AWS OpsWorks API. However, if you prefer directly accessing your Chef Automate server, you can select your EC2 key pair. You can pick any of your key pair and click Next. For the talk right now, we will just skip this step. Now, this is the critical part. Once we get to this step, we need to make sure, this is basically setting up the network and security. At this point, we need to make sure that the VPC is either in the same VPC as your Amazon Linux workspaces, or if you want to establish extra security hardening and you don't want your management server to be in the same VPC as your Amazon Linux workspaces desktops, you can create them in separate VPCs, but then you will need to be able to connect between those two VPCs through VPC peering or some sort of networking. So the key point here is that your Chef Automate server needs to be able to talk to your Amazon Linux workspaces through networking. And it's probably easier to just do it in the same VPC. You will decide the subnet within that VPC, and then you will assign a public IP to it. This is important because you need to be able to access the Chef Automate console. And then you can leave the rest of it as default. Like I mentioned earlier, that you have the ability to configure when you maintain your Chef Automate server. So you can maintain your Chef Automate server on a weekly basis, and you can effectively do it, whichever day you prefer, whichever time you prefer. Ideally, we know that people prefer doing this work during nighttime, and the main reason for that would be most of the people who are using Amazon Linux workspaces are actually working during the day. I would like to clarify that this is the maintenance of your AWS OpsWorks Chef Automate server, and not the maintenance of your Amazon Linux workspaces themselves. Finally, you can configure what sort of automated backups you want to take. You can set the frequency, you can set the time, and so on, how many backups you want to keep. So once you get to the next stage, you can simply click Launch. And what it will do is that it's going to start establishing your Chef Automate server. So as you can see, this is as easy as three simple screens that I went through. And AWS OpsWorks is going to create this server for me. It's going to install Chef Automate on it. It's going to take care of all the licensing requirements and so on. So you're going to get a fully ready Chef Automate server using AWS OpsWorks. Now, two of the key things that you will need to proceed further is to download credentials. These credentials are going to be used to access your Chef Automate dashboard. These credentials are only shown once, so make sure that you download it right now. If, for example, you don't download it right now, or you, for some reason lose it, you will have to unfortunately create a new server. Then the second thing that is important is to download the starter kit. Now, the starter kit basically gives you some of the basic configuration and examples of configuration that you can implement on any of your server that you are going to be managing, Amazon Linux workspaces, and pretty much any machine that you want. A lot of things in the starter kit might be relevant to you depending on your use case. Our use case today is desktops, so we are going to be using the files that are important to us. But basically, you can look at the starter kit and you can see that there's going to be a lot of files that you can configure and reuse to effectively build a configuration file for your desktops. Finally, you will get this information about your Chef server dashboard. This is going to give you access to the Chef Automate dashboard that we discussed using the credentials that we downloaded from here. Now, as I mentioned earlier a little bit in my design here, I mentioned that we are going to use this Amazon Linux workspaces as our workstation as well. So what that means is that once we have an image ready to go for Amazon Linux workspaces, which means that we have a customized bundle that we can continuously launch new workspaces with, which automatically get registered to Chef Automate server. Now, if we want to configure some configuration settings on the Chef server, if we want to, for example, upload a new cookbook, if I want to upload a new recipe, or if I want to send any instructions to my Chef server, I will basically use this Chef DK to do that work. And this Chef DK can be installed on your Amazon Linux workspaces to talk to your Chef Automate server to pass on those instructions. So we're going to do everything in the cloud today. So this process takes about 20 minutes to complete. But what we will do is that we are going to quickly switch into setting up our other artifact. So we are at step one. We did the setup of our Chef Automate server using AWS OpsWorks. Now we need to set up Amazon Linux workspaces for our image preparation, as well as later for our Chef DK. To be clear, we are not going to cover the Chef DK piece in today's talk. We will leave the recipe and cookbook deep dive for a separate one. So workspaces, if you are not super familiar with it, it's actually similar to AWS OpsWorks, but here you are basically setting up Amazon Linux workspaces desktops as opposed to a Chef Automate server. Here, we are going to do these steps quite fast, and if you want to have a link on understanding how to get started with setting up an Amazon Linux workspaces instance, you can quickly Google or check on AWS website to find a getting started guide. So what I've done is that I have created this Chef1 username for my Amazon Linux workspaces, and I'm going to use this workspace today to do all my work. So we'll consider our step one is getting finished. Meanwhile, in the step two, let's log into our Amazon Linux workspaces that we just set up, and let's start configuring it for automatic image creation. So this is something that a fresh Amazon Linux workspaces looks like. You will notice that I used Amazon Linux workspaces client to effectively log into my workspace. So once you download the Chef development kit, as I mentioned in the step here, my server is still getting ready. But as I mentioned, we downloaded the credentials and we downloaded the starter kit. And effectively, this is my credentials file, and this is my starter kit file. So my goal now is to configure this Amazon Linux workspace to be able to register to Chef Automate server once. But then I want to be able to create a custom image from it that can automatically do that for me. So I'll come back here. And effectively, I unzip this file. And as I mentioned, the starter kit is a pretty well-knitted starter kit. It will give you a lot of artifacts, a lot of configurations that you can use to do some of the work on your nodes as they're coming up live. But today we are going to simplify it to effectively achieve our goal of automatic registration. But real quick, if you want to have a quick understanding of this starter kit, we have the policy file.rb. This applies the policy at runtime when you're launching an instance, Amazon Linux Workspaces instance. We have cookbooks here. This is going to have all your configuration file, environments if you want to set any, site cookbooks if you have some cookbooks that are located in some site that you want to pull on runtime. And then this is the key file that we are going to work with, the .chef file. This .chef file is effectively the file or the folder that has the files that we are going to work with today. Once you first download this file, this is going to be named knife.rb. So that method is used for knife bootstrapping, but it's a separate method. But you simply have to rename this file as client.rb. You will also get a private PEM file. And this PEM key is effectively your organization's PEM key that identifies your machine as part of an organization. This is the organization that you will set up in Chef Automate server. For simplicity today, we are going to use the default organization that AWS OpsWorks already set it for you. Once you have the client.rb file, we are going to make some edits. So the first file that you generally receive will look something like this. I just want to extract it again just for you to see how this file looks in default. So you can see that there's knife.rb. You can see I have the private.pam file. If I open the knife.rb, you can see that it's written to take care of a lot of things in terms of configuring your client. This is used for the knife bootstrap method, but today we're using the client URL method of registering a node. You can effectively ignore this, and you can use this client RB file configuration that I created in that file. So you come back to our folder here. Now, what we did here is pretty simple. So I took I put pretty standard configurations here. There's certainly a lot of configurations that you can do in client.rb file. And if you want to learn more about it, Chef has pretty good documentation on the configuration that you have available for client.rb. So just simply search for client.rb and you'll get the documentation with all the attributes you can set with variables and whatnot. So here we did log level. I put it on info location as std out. Just for simplicity, I turned off SSL verification, but if you do want to turn it on, you will provide the CS cert location for your SSL verification, which has the SSL cert in it. And then I will also turn off API certification as well. Again, that's for simplicity. If you want to add that additional control, I've effectively turned off my security settings just to make this up and running. My node name is Pivotal. This is the default node name given by the AWS OpsWorks Chef Automate file. You can change it to your own liking. The client key I'm using right now is the organizational client key, the private.pem file that we just discussed. There's another, probably a little bit more secure way of doing this, and that is using a validator key. In today's talk, we're not going to go into detail on that because we simply want to get something up and running for our Chef Automate server to be able to manage. But if you search a validator key method of registering your client, you will be able to find resources to do that. The main difference between the two methods is that the validator key is effectively a hello key that sends to the server its validation. And once that validation is done, the server sends back a client.pem file that effectively becomes your client PEM key. However, in this method, we are using the private PEM file, which has more privileges than the validator method. And finally, we will have our public URL, or rather the Chef server URL for this specific organization. So make sure that when you are copying your Chef server URL that we created here, make sure that you have the organizations and default in front of it. This is the default organization that Chef Automate is going to create when you do the AWS OpsWorks method. Again, you can create your own organization using Chef Automate, or you can use your existing organization that you already have to do this work. So once I have this, all of these three files, I'm going to simply copy them. I'm going to create a folder in etc drive Chef. This folder is not created by default, so you will have to create this etc/chef folder in your Amazon Linux workspace, and then you're simply going to copy those three files that I mentioned before. So the three files were cscerts, client.rb, and private.pem. These two other files are created after you do the Chef client run. So now that we have given all the files that are required for this Chef client to be configured and registered to the node, now what we are going to do is we are going to download the Chef client on this node, and then we are going to effectively run Chef client on it, which will register the node to AWS OpsWorks for Chef Automate. Now, one thing to remember here is that you can, when a Chef client run is done, it does take something as first-boot.json. And that file effectively can be used to pull in recipes, to pull in cookbooks, so that you do the configuration step at boot. And again, we're going to do that in a separate talk. Okay, so let's open a new terminal window. And here we are going to run the curl command to download the Chef client. Key things to remember here is that it's always better to pin it to a version. And the reason I'm saying that is that currently the Chef client is on version 15. And there were some issues when I was doing this lab with running the Chef client effectively. And I found that the version 14.4.56 was effectively able to run all the configuration steps with Amazon Linux Workspaces. So you want to test which client version is going to work in your environment, and then you want to keep it to that version till you test the new version and then deploy the newer version across your fleet. So simply run this command. It's going to ask me to go into sudo. And then it's going to download and install the Chef client on my Amazon Linux Workspaces. Again, here is the sudo that we're doing. Later we will find out how we can put it into a script. So when this part is done, after that, simply running chef-client will effectively run all the configurations and register this node into the Chef Automate server. Now I'll go into my Chef Automate server dashboard. This is the URL that AWS OpsWorks provided me to access my dashboard. And then once you open this URL, you will need to use the credentials that you got from here, which were the CSV file that we looked at over here. The CSV file that we got here. This one will have your username and your credentials for login. Once you log in, you will see something like this dashboard. And what you want to do is that you want to see the client runs. So once I go into the client runs, I can see that, hey, there's my node that just checked in a few seconds ago. So this is the node that I actually just ran the Chef client on. And then you can ignore the second node for now, because this is the node that will automatically register to the Chef Automate server. So once we are at this stage, now we know that our Amazon Linux Workspaces nodes are actually getting registered to Chef Automate server using this method, but we want to automate it. We want to create an Amazon Linux Workspaces image to deploy new workspaces that automatically register them to Chef Automate server. So there's two things that we will need to do. We will effectively need to run what we did here using a script. And that script is going to be run at the boot time for Amazon Linux Workspaces. Now, as you can imagine, there are many, many ways to do that. You can use cron tab, you can use rc.local file, you can use systemd to run a process. So there's many ways to do it. Today, for simplicity, I'm going to use the rc.local method, which is a very simple script that runs at the boot time. So simply, I'm going to create an etc/rc.d/rc.local text file, and then I'm going to add /bin/chef.sh. You can name this script anything. This is effectively going to be the script that does all of the configuration that we just did here to register Amazon Linux Workspaces as a node. So similarly, what I will do is that I'm going to run change mode on this rc.local file to make it an executable. And this is the command you will use. So going to the chef installation.sh file, what we will do is that we're going to configure the file something like this. Again, this is a script, so you can script it as you wish. A lot of things that you will do in terms of configuration per se will be handled by chef-client if you are using recipes and cookbooks. So highly recommended that you take a look at those, and we will cover those in some other tech talk. It's pretty self-explanatory. Here I'm adding a sleep timer for 600, so just wait 5 minutes, just to get the system ready. We will run the chef the client installation. So this command that we just ran manually, we will run it to basically download and install. We will then run chef client on this. And then we do want to prevent it from running again and again once a node is registered. And then we will basically reset the permissions on the rc.local file once everything is up and running, and so that we can keep our hygiene. And then we will remove this file after one run. So very basic bash script to do this work. After that, I also need to make this bash script executable. So I will use the chain1 command to make this script executable. So now that this machine is ready, I will save everything. I'll save my work. And then I will go back to my AWS WorkSpaces dashboard. And I'll take a look at this machine. This Chef 1 was the Amazon Linux workspaces that I was using. And I want to create a custom image from it so I can repeatedly launch more workspaces. So I will go and I'll create an image. It's going to tell you some best practices in terms of preparation of the image. You can name this image whatever you would like. You can give it a description. And then you're just going to tell it to create that image. So it's basically going to start creating this image. I have created a bunch of these images for testing purposes, and this is the one that I recently created. And effectively what I did after that is that I launched a new Chef Amazon Linux workspace, well, Amazon Linux workspace that can register as a node to Chef Automate server using my custom created image. So real quick for people who are new to Amazon workspaces, you will go and select this. Unfortunately, it's not going to give me an option to create the bundle yet. It takes about 45 minutes to create this image, but let's use this one. I'll go to create a bundle. I'll name this bundle whatever I want, give it a description, select what type of CPU and memory I want, and then select the root volume and user volume sizes, and then I'll create this bundle. This bundle is going to be shown here. This is the bundle that I just created, and now you will use this bundle in the bundle selection screen. I'm just using a fake email address here. So once you get to this place, you will see custom bundles. You will see that my custom bundle is available here for me to launch workspaces from. This new workspace also registered here in my Chef Automate server. So using this method, now every new workspace that you're going to launch using that custom image that we created is going to be automatically getting registered in the Chef Automate server here. Now, moving on. So the next step that we wanted to achieve today was that we wanted to basically run some CIS benchmarks scans and take some configuration management actions. So effectively, what we did till now is we reached the step 3, where we configured our custom image to automatically register Amazon Linux workspaces as a node. So I will go back to my Amazon Linux workspace. And here, there's many things you can do. So you can run compliance scans. You can create scan jobs. You can look at certain assets that are profiles available. In today's talk, we'll take a simple example of CIS Amazon Linux 2 benchmark level 1, and we're going to run that scan on our nodes that we registered. And these are the nodes that I created later, the Amazon Linux workspace desktop, if you will, for your user, rather than the machine that I was using to prepare the image, which is this current machine. So what I do is that, first of all, I need to download a profile. So I can either upload my own profile, or I can pick some of the compliance profiles that are already available. Now, the purpose of the profile is to provide you scanning of your resources. Once you have the data from the profile scan, you can basically use recipes or cookbooks to take action on those scans in order to remediate those issues. So what I did is that I actually did some changes in my machine so it fails the scan. So today we are going to, let's say, pick Amazon Linux 2, benchmark level 1. You can simply get it. Once you get it, you're going to get this profile added here. So this is part of your asset store now. Now you can go into the scan jobs, and what you're going to do is that you're going to create a new job. So when you're creating a new job, you basically want to be able to add a node here. Now, these nodes are a little bit different in terms of configuration than just your configuration management. And the reason of this node of being different could be that the scan job that you're running, maybe you want to run it with sudo privileges versus the other configuration that you're delivering, you want to run it with maybe lower privileges. So there's all sorts of these things you can do in terms of the appropriate privileges that you want to your organization wants you to implement. So here, what I will first do is, if I'm using the method of creating a scan job, I will need to create SSH access to my workspace. And basically what I can do is that I'll go here, I'll do an add node. So if you are interested in learning how to configure SSH on Linux workspaces, there's this link. If you search Linux workspaces SSH, you're going to get this page. It will walk you through the simple steps of configuring SSH. Again, all of this work can be programmatically done using the recipes for Chef Automate. And effectively, when you do that Chef client run that we did in the previous step, it would automatically configure the SSH in your desired fashion. Any SSH users, PEM files, for SSH, as well other configurations that you want to do. So for simplicity here, I just did it manually, quickly. What you can do here is that you can provide a list of IPs here. So a very simple way of thinking about it is that Amazon Linux workspaces are created in a VPC with specific subnets. So here you can provide a subnet or basically a multiple group of IP addresses that have the same SSH PEM file configuration or credentials, if you will, so that you can do it at scale. You can also assign optional names to your nodes here with custom prefix. Here's the SSH credential that I created for this. So you can create additional SSH credentials. Again, this is the UI version of doing these credentials, but you can actually automate creation of even these credentials in your SSH server. So your SSH server has all the credentials to actually go access the nodes to run these scan jobs. Similarly, you can also tag your nodes so that you can have better management. So once you have created this node, it's going to show up here. This is the name of my node that I gave it. It's going to show you that this node is reachable. You want it to be in reachable state before you can run any scan jobs in it. You can refresh the status using that. Once you have the node ready, then you will go and create a new job. You will go here and you will specify rules. So these rules are optional if you want to basically say that, hey, a certain name of my nodes should be running the scan job. You can specify those rules here. And again, these names for these nodes are not the same as your Amazon Linux Workspace's computer name. So you can give them any name that you want for your Chef Automate profiles. You can then go and select the profile you want to run with. So, this is the profile that we imported, the CIS benchmark. And then you can add some schedule that, hey, I want to run it regularly on this cadence, or you can do it on a one-time basis. So what I did is that I ran this benchmark not too long ago. And effectively, like as I mentioned, I did some changes in my Amazon Linux workspaces intentionally so it fails. So once you run a scan job, you can go into the compliance tab and you are going to see that, hey, this is the job that ran with this job ID, and it's telling me that my system is not compliant, and it's going to tell me how many nodes failed. One of my nodes failed. Again, this is the node that automatically got registered, not the one that I used to do image preparation with. And it's going to give you some visualized data to understand the health status of your fleet as it relates to compliance. You can then go into a little bit of detail and see that, hey, what parts of my profile of CIS benchmark actually were passed, what were skipped, what were failed. You can see that 72 of them failed, 69 had critical failures, 70 of them passed. So what you will go and you will effectively get to the metadata stage. You can download this report and basically take those remediation actions. So if you want to go into deep details of your data, here's the deep details of all the stuff that failed. So you can see that mounting of cram file system is disabled, it's not HFS, and I did a bunch of these changes to kind of make my machine not compliant. And effectively, you can fix those changes using your configuration management so that your compliance test passes. So once we are at this stage, we have effectively covered, to recap a little bit, we have effectively covered how to set up a Chef Automate server using AWS OpsWorks. We have covered making an image out of an Amazon Linux workspaces under Chef Automate management as a node using the client method. We also configured our image so that every new workspace that we launch automatically gets registered as a node for AWS OpsWorks for Chef Automate. We ran an example of CIS benchmark scans on our node, failed, but we did the test, and now basically we have all the tools to be able to remediate those actions. So let's take a simple example of configuration management actions. And to kind of elaborate on how configuration management works, let's take the example of PC over IP clipboard management that we just discussed a while ago. So effectively, what you can do is, first of all, let's look at some of the things that PC over IP configuration management allows us to do. So what you will do is that you can simply type man. You'll get the a manual of PC over IP agent configuration for your Linux workspace. It's going to give you a bunch of options here. You can see that you can set build to lossless. You can do maximum PC over IP session bandwidth. But today we are going to do some security settings. You can also configure some security settings. You can configure image quality. There's a lot of settings over here. Simply put, what you will do is that you will take this directive and basically pass that code and effectively run it on this Linux workspace. What that will do is, it's going to set that setting at that level, and second, every time your client runs, every time your client run happens, it's going to make sure that that setting is back to that state, even if someone, for example, decide to change it. Now, one of the key things that, as we discussed, is the setting for clipboard in the PC over IP configuration. And effectively, what you can do there is that you can set the clipboard state as it is mentioned here. You can set it to disabled in both direction, enabled in both direction, or enabled in client to agent only, or agent to client only. So you have 4 options to set the clipboard. So the command you can simply use is PC over IP server _ clipboard _ state and pass the variable here. Again, how you will implement it and what we will do in a separate talk is that you will run this as a recipe in your Chef server, and you can make it part of a cookbook. Now, every time there is a client run, it's going to make sure that that setting is according to your desired state. One of the key things that customers ask us is that what if the user changes the clipboard for that file? So a couple of things there. One, in any case, when the user changes that clipboard file, they will have to recreate their session or reboot their workspace, so the effects can happen only after. And then second thing that, so that provides you that extra layer of security. And second thing is that, again, every time this command is being run, you will be able to reset that command back to what it was there. So effectively, you can use an enforcement mechanism here where you can, every client run, you can enforce this setting, and at the same time, you can basically do a reset of that setting. And what I mean by that is that in case of the client clipboard redirection or clipboard state, it's getting affected at the next session. So what you can do is that you can kill the session for users using a recipe every time this state is not in the desired state. More on that in a separate talk. And now we will take some question and answers.